Here's a map of our local superclusters, including the Virgo supercluster. As you can see, galaxies and clusters of galaxies are not uniformly distributed in the universe. Instead, they collect into vast clusters, filaments and walls of galaxies, interspersed with large voids in which very few galaxies seem to exist. A filament is constructed of galaxies and galaxy clusters. The Perseus-Pegasus filament is an example. Walls are much wider and thicker than filaments. Here we see the Fornax, Centaurus, Sculptor, and the Great Wall, or Coma Wall. The Great Wall is one of the longest known superstructures in the universe. It is approximately 200 million light-years away and measures over 500 million light-years long, 300 million light-years wide, and 16 million light-years thick. Voids are the vast empty spaces between filaments, which contain very few or no galaxies at all. There are 25 major voids in our local superclusters. Only a few are marked here. The Sculptor void is the largest in the nearby universe. Let's take a look at some of the superclusters and some of the galaxies photographed by Hubble that are contained in these superclusters. The Hydra supercluster is close to the Virgo supercluster and similar in size and shape to it. It's about 100 million light-years long and contains the large Hydra galaxy cluster. This map plots every bright galaxy in the supercluster. The galaxies in the supercluster range from 150 to 200 million light-years away. Here is a picture of the Hydra cluster. The white blobs in this picture are the galaxies in the cluster. The bright orange star in the center is a nearby red giant in the cluster's line of sight, not actually in the cluster. Here's a unique galaxy pair in Hydra. Through an extraordinary chance of alignment, a face-on spiral galaxy lies precisely in front of another larger spiral. This lineup provides us with a rare chance to visualize dark material within the front galaxy, seen only because it is silhouetted against the object behind it. The bright blue stars forming a pinwheel shape near the center of the front galaxy have formed recently from interstellar gas and dust. A small red patch near the center of the image is the bright nucleus of the background galaxy, NGC 3314b. The Centaurus supercluster is the closest neighbor of our Virgo supercluster. It contains a number of large galaxy clusters, including the Centaurus cluster. The galaxies in the supercluster range from 150 to 200 million light-years away. This map plots the brightest galaxies in this area of the sky. Here is a picture of the Centaurus cluster. It is one of the most massive assemblages of galaxies in the nearby universe. Note that the plane of our galaxy cuts its way through this region of sky, so any photographs will be contaminated by a large number of foreground Milky Way stars. Here's a magnificent view of the spiral galaxy NGC 4603 in the Centaurus cluster. It is the most distant galaxy in which Cepheid variables have been found. Clusters of young bright blue stars highlight the galaxy's spiral arms. In contrast, red giant stars in the process of dying are also found. Only the very brightest stars in NGC 4603 can be seen individually. Much of the diffuse glow comes from fainter stars that cannot be individually distinguished. Here is another galaxy in the Centaurus cluster. The image shows NGC 4622 and its outer pair of winding arms full of new stars shown in blue. Astronomers are puzzled by its clockwise rotation because of the direction of the outer spiral arms are pointing. Most spiral galaxies have arms of gas and stars that trail behind as they turn. But this galaxy has two leading outer arms that point toward the direction of the galaxy's clockwise rotation. Located about 130 million light-years away in the Centaurus cluster, NGC 4650A is one of only 100 known polar ring galaxies. Their unusual disk ring structure is not yet well understood. One possibility is that polar rings are the remnants of colossal collisions between two galaxies sometime in the distant past, probably at least 1 billion years ago. NGC 4696 is an elliptical galaxy in the Centaurus cluster. In fact, it is the brightest galaxy in the cluster. This composite image was taken in a study of the galaxy's central black hole. It shows a vast cloud of hot gas in red, surrounding high-energy bubbles 10,000 light-years across in blue. The green dots in the image show infrared radiation from star clusters on the outer edges of the galaxy. The Perseus-Pisces supercluster is a long, dense wall of galaxies with a length of almost 300 million light-years that is around 250 million light-years away. It is one of the largest known structures in the universe. This plot of the brightest galaxies in the supercluster show how prominent it is. At the left end of the supercluster is the massive Perseus cluster, one of the most massive clusters of galaxies within 500 million light-years. This picture shows the central part of the Perseus cluster. As with the others we've seen, it is crowded with Milky Way stars in the foreground that show up as faint dots. Here we are zooming into the giant elliptical galaxy NGC 1275 in the Perseus cluster. We see fine, thread-like filamentary structures in the gas surrounding the galaxy. The red filaments are composed of cool gas being suspended by a magnetic field and are surrounded by the 100 million degree Fahrenheit hot gas in the center of the Perseus galaxy cluster. The filaments are dramatic markers of the feedback process through which energy is transformed from the central mass black hole to the surrounding gas. The filaments originate when cool gas is transported from the center of the galaxy by radio bubbles that rise in the hot interstellar gas. The Coma supercluster is a nearby supercluster of galaxies that includes the famous Coma cluster, Abell 1656, located 300 million light-years from Earth. It is roughly spherical, about 20 million light-years in diameter, and contains more than 3,000 galaxies. Being one of the first superclusters to be discovered, Coma supercluster helped astronomers understand the large-scale structure of the universe. This map plots the brightest galaxies in Coma supercluster's region of the sky. The Coma cluster has received a huge amount of scientific research. This is partly because it lays a long way from the plane of our galaxy, and it is largely unobstructed by any gas, dust, or foreground stars. There is also one obvious foreground star in this image. It's less than 1/millionth of the distance to the Coma cluster. Here we are zooming into NGC 4921. It is one of the rare spirals in the Coma cluster, and a rather unusual one. It is an example of an anemic spiral, where the normal vigorous star formation that creates a spiral galaxy's familiar bright arms is much less intense. As a result, there is just a delicate swirl of dust in a ring around the galaxy, accompanied by some bright young blue stars. NGC 4911 contains rich lanes of dust and gas near its center. These are silhouetted against glowing newborn star clusters and iridescent pink clouds of hydrogen, the existence of which indicates ongoing star formation. 4911 and other spirals near the center of the cluster are being transformed by the gravitational tug of their neighbors. In the case of 4911, wispy arcs of the galaxy's outer spiral arm are being pulled and distorted by forces from a companion galaxy, NGC 4911A, to the upper right. The resultant stripped material will eventually be dispersed throughout the core of the Coma cluster, where it will fuel the intergalactic population of stars and star clusters. Here are the distances to a few additional superclusters in our local group. Hercules is 400 million light-years away. Leo is 450 million light-years away. Shapley is 500 million light-years away. Orologium is 900 million light-years away. And Corona Borealis is 1 billion light-years away. There's one more thing about the galaxies in our local superclusters. They all have an unusual, peculiar motion. Normally, galaxies are expected to have a motion consistent with the Hubble flow. That is, given the Hubble law and the distance to the galaxy, its velocity is set. But in our local area, within 1 billion light-years, there is an additional flow superimposed on the Hubble flow. It appears that our galaxy, and a large number of the galaxy superclusters in our area, are flowing toward what is called the Great Attractor. Initially, it looked like the Great Attractor was located close to the Norma cluster, not too far from the Centaurus supercluster. But Norma is so close to our galactic plane, or area of avoidance, that we cannot see into it very well. More recently, though, updates to motion vectors indicate that the flow is not so much to the Norma cluster, but to the much more massive Shapley supercluster behind it. Now let's take a look at a few more galaxies found in our local superclusters. This is an image of an unusual edge-on galaxy, revealing remarkable details of its warped dusty disk. The strong warping of the disk indicates that this galaxy has recently undergone a collision with a nearby galaxy and is in the process of swallowing it. In the outer regions, especially on the right-hand side of the image, we see that the twisted disk contains not only dark dust, but also bright clouds of blue stars. This shows that hot young stars are being formed in the disk. Astronomers believe that the formation of new stars may be triggered by collisions between galaxies as their interstellar clouds smash together and are compressed. The appearance of a galaxy can depend strongly on the color of the light with which it is viewed. This galaxy, when seen in visible light, exhibits tightly wound spiral arms that give it a pinwheel shape, similar to that of many other spirals. However, when the galaxy is viewed in ultraviolet light, its shape is startlingly different. Ultraviolet light has a shorter wavelength than ordinary visible light and is emitted from stars that are much hotter than the Sun. At ultraviolet wavelengths, which are rendered as blue in this Hubble image, we see a spectacular, nearly circular, bright ring surrounding its nucleus. The ring marks the presence of many recently formed hot stars. This spectacular edge-on galaxy is believed to be the home of an intermediate mass black hole that may have been stripped off of a cannibalized dwarf galaxy. The estimated 20,000 solar mass black hole lies above the galactic plane. This is an unlikely place for such a massive black hole to exist unless it belonged to a small galaxy that was gravitationally torn apart by this one. The circle identifies a unique X-ray source that pinpoints the black hole. Here we are zooming into Stephan's quintet. As the name implies, it is a group of 5 galaxies. The name, however, is a bit of a misnomer. Studies have shown that group member NGC 7320 is actually a foreground galaxy. At 40 million light-years, it is about 7 times closer to Earth than the rest of the group. 3 of the galaxies have distorted shapes, elongated spiral arms, and long gaseous tidal tails containing myriad star clusters, proof of their close encounters. These interactions have sparked a frenzy of star birth in the central pair of galaxies. 7319 is a barred spiral galaxy with distinct spiral arms that follow along 180 degrees back to the bar. Continuing clockwise, the next galaxy appears to have 2 cores, but it is actually 2 galaxies, 7318a and 7318b. NGC 7317 is a normal-looking elliptical galaxy that is less affected by the interactions. These farther members are markedly redder than the foreground galaxy, suggesting that older stars reside in their cores. This visible light Hubble picture reveals an intergalactic pipeline of material flowing between 2 battered galaxies that bumped into each other about 100 million years ago. The pipeline, the dark string of matter, begins in 1410, the galaxy on the left, crosses over 20,000 light-years of intergalactic space, and wraps around 1409, the companion galaxy on the right. Here we are zooming into 3 galaxies that appear to be partially overlapping in the image, although they may be at somewhat different distances. The spiral shapes of 2 of these galaxies appear mostly intact. The third galaxy, on the far left, is more compact, but shows evidence of star formation. This image shows the diverse collection of galaxies in the cluster Abell S0740. The giant elliptical ESO 325-G004 looms large at the cluster's center. In the course of analyzing this Hubble image, astronomers discovered that ESO 325 is actually a gravitational lens. This means that the focusing power of the enormous mass making up the galaxy caused the light from some distant object, probably a distant dwarf galaxy, to be deflected and magnified. As a result, the more distant galaxy appears brighter and distorted into the shape of an arc or ring, known as an Einstein ring, because the phenomenon was first predicted by Albert Einstein. A nearly perfect ring of hot blue star pinwheels about the yellow nucleus of an unusual galaxy known as Hoag's object. A blue ring, which is dominated by clusters of young massive stars, contrasts sharply with the yellow nucleus of mostly old stars. What appears to be a gap separating the 2 stellar populations may actually contain some star clusters that are just too faint to see. Curiously, an object that bears an uncanny resemblance to Hoag's object can be seen in the gap at the 1 o'clock position. The object is probably a background ring galaxy. Here's another view of our local superclusters. I've circled the ones we've covered. The empty space is the area we can't see due to the clutter from our own galaxy's disk. Within this 1 billion light-year radius from us, there are 100 superclusters, 240,000 galaxy groups, 3 million large galaxies, 60 million dwarf galaxies, and 250,000 trillion stars. At this range, the Milky Way is too small to show up. Our entire local volume is little more than a dot. But the entire map only represents about 7% of the entire visible universe. In this segment, we've seen several interacting galaxies. So before we conclude the video book covering the cosmos as a whole, we'll take a closer look in our next segment at what it means for galaxies to collide.